Hello students, welcome back to my YouTube channel. In this video lecture, we are going to going to continue solving questions from revision questions chapter of Oxford General Navigation book. So far, we have done many questions. I hope you have understood them, comfortable solving them. If you have any questions, let me know. In this video lecture, we are going to try new questions, look at how to solve them, know the tips, tricks, any conceptual knowledge, understanding, so on and so forth. So let's start with today's question number one, question 61. You're homing to overhead a vortex station and will descend from 7,500 QNH, that is mean sea level, to 1,000 mean sea level by 6 nautical mile DME. Your ground speed is given, rate of descent is given. What range from the vortex station do you commence the descent? Very important question. So here is your vortex station. Here is your aircraft. Okay. So your aircraft is at flight level, is at correction altitude 7,500 feet, and you have to descend to altitude 1,000 feet. And that should happen when you are 6 nautical mile away from the vortex station. So you should descend to 1,000 feet, altitude 1,000 feet, and you should be 6 nautical mile away from the VOR station. So you have to meet two conditions. The first, descend to altitude 1,000. Second, be 6 nautical mile away from the station. Okay, so this one. Okay, you have to find this total distance from the VOR station. Okay, out of that total distance, this much is 6 miles. Now let's find this distance and then add 6 to that distance. Okay, so step 1, change in height. The change in height is 7,500 to 1,000 feet. So change in altitude is equal to 6,500 feet. Okay, step number 2, time taken to descend is distance divided by speed. Now distance is, we do not know, that's fine. Distance also we have to find out, and speed we have 156 knots. So I'll erase this. I'll write step number 2. I'll write this: rate of descent equals to 1,000 feet per minute. Right, 1,000 feet per minute. Now we have to descend a total descent equal to 6,500 feet. If it takes 1 minute to descend 1,000 feet, it will take 6.5 minutes to descend 6,500 feet. Right. Now we will go to step number 3, in which we will find distance, which is speed into time. Speed is 156 knots. Time is 6.5 minutes. So 156 into 6 minutes is 15 hours 36 minutes. Correction, is 15.6 nautical mile. Okay, 15.6 nautical miles. So this distance is 15.6 and this distance is 6. So total becomes step number 4. Distance from vortex will be equal to 15.6 plus 6, which is 21.6 nautical miles or 22 nautical miles. So correct answer is option A, the closest option. Simple. Next. Question number 62. A rhumb line is the vertex of a conformal polymorphic projection, a straight line on a Lambert's chart, a line which cuts all meridians at equal angle, shortest distance between 2 points on the earth. So correct option is C. By definition, a rhumb line is a line of constant direction. Next, 63. You fly from 49 north to 58 north along 180 east-west meridian. What is the distance in kilometers? So this is your latitude. Correction. This is your longitude, 180 degree, east or west. You are in the northern hemisphere. 49 north is your departure. 58 north is your destination. You travel from 49 to 58. You have to calculate this distance between these two locations. Now this is nothing but your great circle track. So great circle distance is difference in latitude in degree multiplied by 60. So when you fly north or south along a meridian, we are actually flying a great circle by definition. So difference between these two latitudes is 58 minus 49, 9 degree into 60, which is 540 nautical miles. Convert this into kilometers, multiply by 1.85999 kilometers. So delta is the correct answer, the closest. Simple. Next, on a direct Mercator chart, the full length of the parallel of latitude at 53 north is 133 centimeter long. So chart distance is 133. Is the scale of the chart at 30 south latitude. Okay, at 30 south latitude. On a direct Mercator chart, all parallels of latitude are straight line. On a direct Mercator chart, all parallels latitude are straight lines. Remember this. Okay. So if this is your flat representation of the Earth, this equator, one latitude is 53 north and the other is 30 south. 53 north and 30 south, the second one. So this 53 north will be a straight line, so will be this 30 degrees south latitude. So chart distance of 53 north is 133 centimeter. So will be the chart distance of 30 degrees south 133 centimeter, because both are straight lines equal in length. Earth distance. Now what will be the earth distance at 53 degree north or 50 degrees south? Earth distance is nothing but the rhumb line distance. The entire rhumb line distance of 30 degrees south latitude. So it will be equal to rhumb line distance d long into cos lat. Now rhumb line distance at 30 degrees south latitude is d long. So you encircle the whole earth at 30 degrees south latitude. So 360 degree into 60 into cos 30. So 360 into 60 into cos 30 is 18,706 nautical miles. Now we will find scale. Scale is Chart distance upon Earth distance. Chart distance is 133 centimeter divided by Earth distance 18,706 nautical miles. So 133 centimeter divided by, convert nautical miles into centimeter, 18706 into 1852 meters into 100 centimeters. So 3464351200. So now we want 1 in the numerator. So divide numerator and denominator by 133. So you get answer, final answer as 1 divided by 26047,753. So this is the scale at 30 degrees south latitude. Okay. 26 100,000 10,000 lakh 10 lakh crore. 2 crores 60 lakh something. So the closest option here will be option delta. 100,000 10,000 lakh 10 lakh. Yeah. So 1 2 crores 60 lakhs. Okay. So simple but very important. Next. What is the highest latitude on the earth at which the sun can be vertically overhead? So the sun is vertically overhead at Tropic of Cancer, 23.5 degree north or 23.5 degree south latitude. So this is your earth. Okay. We have equator, then we have Tropic of Cancer, and then we have Tropic of Capricorn. So the sun travels between these two latitudes, 23.5 degree north, Tropic of Cancer, and 23.5 degree south, Tropic of Capricorn. Okay. So the sun will be directly overhead at any latitude between these two latitudes. Okay, any latitude between these two latitudes, the sun will be directly overhead, meaning the sun will directly pass over your latitude. Okay, beyond these latitudes, the sun will not be directly overhead you. It will be at an angle less than 90 degree. Okay, so the highest latitude is 23.5 degree north in the northern hemisphere, 23.5 degree south in the southern hemisphere. So remember this, okay? Therefore, option A is the correct answer. Next, question 66. Track is given, task is given, winds, variation, deviation are given. What is compass heading and ground speed? Okay, so let's find true heading first. So, true heading will be equal to how much? So let's substitute the values in your CH3. Yeah. So track is 090. Use wind correction option. Task is 460. Winds are 360 at 10. So your true heading is 77 and ground speed is 449. So true heading is 77. So true heading is 77. Ground speed is 450. Variation is 12 east. Magnetic will be least. So 77 minus 12, 65. Deviation will be minus 2 west. Deviation west compass west. So 65 plus 2 is 67. So final answer will be compass heading will be 067 and ground speed will be 450. 68. The angle between true north and magnetic north is variation. Aircraft is at 10° north and is flying north at 444 kilometers per hour. So let's draw this meridian. Initial location is 10° north and it flies north in the northerly direction at a speed of 444 kilometers per hour. That is equal to 240 knots and time is 3 hours. So distance is speed into time into 3, which is equal to 720 nautical miles. Okay. When we travel northwards along a meridian, you fly a great circle track. So great circle distance will be d lat in degree into 60. So 720 equals to d lat into 60. D lat will be 720 by 60, which is equal to 12 degree. Now when you are in the northern hemisphere and you travel northerly direction, the latitudes increase. So new latitude will be your initial latitude plus d lat. So 10 north plus 12 is 22 north. So new latitude is 22 north. Option C. Okay, simple. Next. Question 70. You are at position A, 55° north latitude, prime meridian. B is at 54° north latitude and 10° east. If the average true course of the great circle, now average great circle means they are indirectly telling you line direction 100. Okay. What is the true course of the line at point A? So this is your A, 55 north, 0° east west. This is your B, 54 north, 10 east. This is your great circle. This is your rhumb line. Okay. What is the course of rhumb line at point A? Average true course of the great circle is 100. So average great circle is nothing but this. Okay, at this specific point where it will be equal to your rhumb line track. Okay, where it will be equal to your rhumb line track. So rhumb line track at A is nothing but 100 as given in the question. Okay, so that's it. So if they ask you to find great circle track at A, so great circle track at A will be rhumb line track at A minus convergency angle. Convergency angle is nothing but this angle, right? This small angle between rhumb line and great circle. So great circle at A will be this whole big angle minus convergency angle. Convergency is d long into sine lat. D long is difference between the longitudes 10 degree and 0 degree, which is 10 degree. Latitude 55 and 44. The mean latitude is 54.5. So sine of 54.5 into 10 is 8 degree. So convergency angle will be 4 degree. So great circle at A will be rhumb line at A minus convergency angle. So 100 minus 4, which is 0.996 degree. Okay, it was not asked, but still I have showed you how to do it. Next. With this, we will do the next questions in the next video lecture. Do practice all the questions we have done in this video lecture uh, and do practice it multiple times. After practicing one or two times, the next time when you practice these questions, do them without looking. Okay. Subscribe to this channel, share this video with your friends, and like this video lecture. See you in next time, and all the best. Take care.